why use an Elos scan bodies, right? That's there's so many different scan bodies on the market. This is just our observations on intraoral scans that we get in from different um, from different dentists, and we have scan bodies used by every single system out there. We get the scan bodies in that, and sometimes it's difficult to um, to find out which scan bodies are which and how to identify them one from the other and everything else. And I'm sure every lab deals with that one way or another. What we have here is this an article from the Journal of Prosthodontic Dentistry, September 2018, and it's a systematic review of intraoral scan bodies in implant dentistry. And I really think it's an excellent article, so you can resource that article. But it's a great comparison of all the different types of scan bodies. And this is just a little snippet of scan bodies. There's even more scan bodies that are out there, but it's a great comparison of all the different scan bodies. And if you look at the top row of the top view of the scan bodies, you'll see with the Elos scan body where the arrow just showed up, how the screw hole is very small. So you're getting more of a scan body area in that spot. And if you look along the bottom, you'll see the everything that's the metallic color or the purple or the blue, like on the Elos. These interfaces are metal, whereas the other ones they're just part of the peak scan body. What we've noticed, and we had this just happen in Roadsart Dental Lab last week, a doctor was scanning for a particular implant system, and they were using their scan bodies, and I guess the interface to the implant has wore out a little bit. And what we're doing is when the doctor was tightening down the screw, he's just getting a slight creepage of the orientation of that scan body. And we did 2 cases with them, and both cases were exactly out, that exact little tweak. So we narrowed it down to the scan body. So he's just getting rid of that and reordering a scan body for that implant system. We would have recommended Elos, but Elos didn't have a scan body for that implant system yet. The identification numbers that you notice on the side on the panel, the IO3B-D, we recommend to all the doctors to put that in the message. When you do your intraoral scan, you have a little message box there before you send it off. Just put in the message what scan body you used, and that will help us as dental labs a lot more in lining up the scan bodies. Next slide, please. So using a scan body, most of you know this already, but I'll just talk about it. You scan the upper, scan the lower with the healing cap in place of the implant. Once you've scanned the upper and lower, and the reason why you do that is so that you can get the contact areas of the adjacent teeth. Once you unscrew the healing cap, make sure there's no bone growth over the implant, and where the scan body will be placed in. The scan body should be able to lock into place, and then you screw it down at 5 Newton centimeters, and then you scan the scan body. They have 2 drivers, and the only difference with the drivers is the neck of the screw handle. Elos has a specific driver for the Elos scan bodies, and that driver works with every single implant. Okay, next slide, please. So we get constantly asked cleaning and sterilization. Elos has done this excellent PDF, this booklet or PDF flyer, and we will be supplying you with that flyer, with that PDF, when we send you off information with the questions and answers. So once you've scanned it and you unscrew that from the patient's mouth, just drop it in tap water. And the reason for that is if there's any blood or saliva or anything on that scan body, you're putting it in a moist environment, it won't adhere to the scan body. And then after that, completely submerge it in the scan body in a mild cleaning solution for 5 minutes. Again, on the sterilization and cleaning guide, they go into more detail on that. And I'll just leave it for you guys to read that. Use a soft bristle brush and a syringe to flush out the screw area of the channel. And then rinse it again and then follow the packaging and sterilizing procedures. Okay.
My name is Kasper. I'm here with my good colleague Ralph.
Hello.
Today we're going to be talking about the benefits and best practice of digital workflow using the open digital libraries. We look forward to be part of this webinar hosted by Emerald Dental Works. And let's get started. And just a short introduction to the Elos Medtech group. Elos Medtech is a contract manufacturer within the medtech industry. Currently, we have 5 production facilities on 3 different continents. We are serving 3 different markets: dental, orthopedic, and life science. Whereas the dental business unit is based out of Denmark. We are currently having above 600 employees worldwide.
Okay, I think today as a lab owner or dental technician, it's more and more important to have an open digital workflow, because today you are maybe stuck in a CAD/CAM environment, but you get your files, your information from different resources. And so it's very important to have this.
Exactly, I agree. And that's why the philosophy for me has always been to have an open digital workflow. We have our free libraries. It always exports the correct connections. There's no dummy interfaces. You also see it when we go through the integration part that we did a lot with our scan bodies, for example, is to make sure that it's an open digital workflow that's accessible for everybody. Okay, but let's start looking at the agenda, Ralph. What do you have for us today?
Yeah, so it starts with the question, what is an implant library? We want to give you a deep insight in the structure of an implant library. Then we bridge to the scan body, which is a key access to getting in the implant library and into your digital workflow. And the last section is maybe one of the interesting things, because we are showing some videos about tips and tricks in the digital workflow.
I'm looking forward to that. So Ralph, what is an implant library then?
Okay, it's easy to explain. An implant library is an exact digital copy of the physical implant components arranged in a precisely aligned assembly. So it's maybe you can say it's a digital twin of the physical parts.
Exactly. But let's have a deeper look at the actual components within the library and how it actually interacts with the different softwares.
Okay, let's start.
Okay, so next bit is the importance of the scan body. So what do we have here, Ralph? What are we looking at?
Yeah, of course. It always starts with a scan body in digital workflow. Yes. So this is the first step, and it's very important to transfer the exact position of the implant from the patient's jaw, from the master model to the CAD software.
Exactly. So what we're actually seeing here is only the top part of the scan body. Yes. You talk about the scannable part of the scan body.
Right.
So this is all we need to see in the library. We don't have any connections that is governed by the coordinate system, right?
Yeah.
Yeah, so what we have here on the picture is that you kind of see that the edges of the scan body is removed. Why is that?
Yes, because if you're looking deeper in the technical structure, how your scan body is detected, you always have point clouds. Yes, and that means always that if you have sharp edges, you're getting artifacts by connecting these point clouds by lines. Yes.
Yeah, removing these non-essential parts of the scan body, we are achieving a higher accuracy, we're achieving a higher alignment of the scan body, right?
Yes, it's a resource of errors, the edges, so we don't need that.
So when talking about the accuracy, and how do we transfer the accuracy from the scan to the CAD software?
Yes, that means you have to transfer the internal geometry to an external geometry, which is visible or detectable by the laser scanner or whatever scanner. Yes. So what do you want to transfer? So on the one side, you want to transfer the height of the implant shoulder,
which we're seeing here.
Yes.
So and that's, I guess that's why we have the importance here by having a large surface area on top. We have a flat surface that gives you a good scanning area and able to control the height. Is that what we're looking at here?
Yes, that's what we are looking here. So the height between the implant shoulder and the top surface of the scan body is very crucial.
Yeah,
Yes.
especially if you have like a bridge solution where you have multiple implants.
For sure, yes.
Yeah.
And I think if you development of a scan body, you have to balance it, because you can say, okay, it's the best to have a big surface on the top for matching.
Yeah.
But on the other side, you have the usability. That means you have narrow gaps inside the jaw, in between the tooth, and so on. So you have to balance that. That means a small screw channel is very important, because the screw channel isn't detectable by the scanner.
Exactly. So we just want as big surface area as possible to get that nice alignment.
Right.
So this gives us the height. If you look at the rotation bit, which is of course important if you have an engaging solution. So what controls that?
Yes, you see this blue marked beveled surface
Yeah, yeah.
on the side. Yes, this gives you or transfers the orientation of the interface connection. So if it's a hex or octa or whatever geometry, it's in a relation to this beveled surface. Yes,
Exactly. So by having the top surface and this bevel shape, we actually get the exact height for the positioning of the implant, but we also get the rotational
Right.
position of the implant, which then leads into a coordinate system,
Right.
basically.
and as a dental technician, you know this is very crucial.
Exactly.
Yes, because the internal connection is so important for the fitting to the implant, to
Yeah.
your abutment.
Great. So next up here, you mentioned the screw.
Yeah, the screw is very different depending on
Yeah.
the scan software or the CAD software. Sorry. So sometimes it's just a nice to have feature, like in Exocad, because it's just for visualization. Because when you're going digital, you don't have to fix anything with the screw.
No, of course.
Yes, but there are also other reasons for the screw, especially in 3-shape, because the screw diameter of the head generates the screw channel in your of your abutment later. Yeah, so this is an important part, but not for all the CAD software.
No.
It's different.
That's right. That's right. Exactly. So exactly for this type of screw. So the screw head in 3-shape would actually generate both the seating surface, but also the screw channel.
Yeah, so when you are going direct to the implant without an abutment in between, then you need the layer for the screw head. And this is also generated by the screw head, especially when we're talking about 3-shape CAD software.
Exactly. And that's why we're going back to the OpenDigital workflow. Here at Elos, we always use the real files. So what you see in the library is actually the real screw. In this case, I think we're looking at a CC platform from Nobel, but it actually has the genuine screw seating connection. It's not an Elos mock-up screw you're seeing. You're actually seeing the real screw connection within the library. I think this is an important point as well.
This is an important point, especially when you are not so comfortable with the digital workflow. So it's nice to see the analog parts to go into the digital workflow. Yes.
So you can actually match your hardware part with the
right.
digital part.
It gives you a better idea of construction and so on, I think.
Absolutely. So we still need some kind of prosthetics. We need an abutment, right?
Right.
So this must be the important part of the restoration, because we need the prosthetic.
Yes, you might think so.
Yeah.
Yes, because for sure, physically, it's a very important part. Yes, because we are talking about quality, about fitting, everything. But in a library, it's not important. Yes, it's just a nice to have feature to see what you are doing. Yes, but it's not important for creating your abutment. This will be shown in another slide, the next slide.
Okay, so here we have the important part, I guess. What do you call this? What do we have here?
Yes, we call it the base file or the connection geometry. Yeah. So it's not a physical part, but it's a very important part because it generates the inner geometry of your designed abutment.
Okay, so this means this is actually where you see the library in function, where you have the library part that is kind of merged with the anatomical design that you're doing in the CAD software.
Yes, and therefore it's very important, and its correct alignment to the scan body is very crucial for the process.
So if you're looking at a normal crown where you can actually you can influence the cement gap here and say, well, I want this kind of fit, my doctor wants this kind of fit. So here you're actually having a library file that you can't influence. So the actual cement gap, where does that come from?
Yeah, let's go to the next sheet. So as you can see here, it's a section view. and you can see that the base file has a predefined offset around the titanium base, but it's not the same in all sections of the titanium base. So for example, in the protection zone for the rotation, it's very, very tight. Yes, or also it goes to the margin area around to maybe 0 microns. Yes.
Yeah, so here we actually see the core of the library. In this case, we're talking about a type-based solution where we have the cement gap fit organized into the base file of the connection geometry that you talked about, governing the exact cement space needed between the tie base and the mill restoration. I know here in the Elos libraries, we have a preset of the cement gap, which is actually around 60 microns, because we want to take into account that you also have some small tolerances when you're milling. We did the study on the bonding, where you see, well, at which layer of cement gap you actually have the strongest bonding effect. So this is where we actually control it. This comes from the core of the library.
Right, and you might thinking, why is the quality of this fitting area sometimes so different in my lab? Yes. So the reason could be you have a lot of dependencies in your workflow. That means you have different toolware, or you have different machines with different accuracy. You have different milling strategies, and for sure you have the human factor, which means you have different methods of brushing out the zirconia abutment after milling before sintering. Then you have different zirconia qualities with different shrinking factors, different sintering processes, different sintering oven. So it means you have to get a good balance in your base file. Yes.
Exactly. And this is actually also, for our sake, it's kind of like the crucial part in the whole process, is where you go from the digital and you go into the virtual reality, basically. Right. You have the digital virtual world, you start producing your restorations, and now you actually have a physical component in your hand, which is, as you said, is governed by a lot of different factors.
Right. You cannot cover all these dependencies just with one base file. So, but this is a good balance, and it fits for mostly all the, let's say, constellations in your lab. Yes, but I think if you want to influence that, you have to influence it in the CAM software. Yes.
Okay.
But this is another task we are talking about maybe in the next webinar.
Absolutely. Absolutely. So let's look at something where you're still going from the digital world into reality, but here you actually may have an opportunity to influence your actual output. So what are we looking at here, Ralph?
Yes, you see on the sheet is transparent blue geometry.
Around the analog.
Yes, it covers it like a shell. Yes, this is the placeholder file. It's, so to say, this, it generates the slot or the hole into the model for this digital implant analog. Yes.
So you could actually say that this file kind of is the same as the base file for the tie base, whereas the tie base itself holds no significance, but the actual base file around it does. Because is that the same here?
Right. It's nearly the same. So you have predefined offsets, but you can influence it in your CAD software. So that means you can expand or tighten this hole by using different settings in your CAD software.
So of course, to compensate for your printer.
Yes, you have so many different dependencies in your printing process. You have different resins, you have different light sources, a different post-processing.
And again, the human factor, I guess, the overall maintenance of your printer will also interact with the accuracy of your print.
Absolutely. Yes, absolutely.
Okay, Ralph, but let's look at the Elos Accurate scan body. So you're saying that the scan body is kind of like the crucial bit when we talk about a digital workflow. Is that right?
This is absolutely right. It's the key element to get into open digital workflow. It transfers the implant position, as we learned in the section before. Yes. So especially today, in former times we had the desktop scanning mainly. Yes. Today we have always intraoral scanning. That means a significant change in requirements for scan body. Yes. In addition to the already mention technical requirements of the digital workflow in terms of precision and perfect transfer of the implant position. There are also higher requirements today regarding usability when using it in a patient's mouth.
And cleanability.
For sure. That's also an important point.
Yeah, and looking at the Elos Accurate scan body, it's both for intraoral use and it's for desktop use or lab scanning.
Sure.
It's the same product. It could be facilitate both workflows. And looking at this cross-section we have of the scan body, here you most definitely see the unique features of the scan body. As we mentioned earlier, when we talk about the scannability and the large surface area, we have what we call the unique small screw channel on top, right. Which is suitable for the Elos driver, of course, that fits all the scan bodies, but it also enables a large area, which is small hole. We have the embedded screw, meaning that you can actually not drop the screw. It's embedded within the scan body, and even though it is embedded, you talked about the regulatory requirements. We have the cleanability. You can clean it. Yeah. It's easy to clean. We have some features on the scan body saying, well, we have the color coding that match the implant. So working in a clinical situation, it's easy to see where the scan body actually fits, which implant it fits. We have the narrow tapered design of the scan body, which allows it to actually seat in the implant without having to interfere with both the soft tissue and the bone overgrowth and so on. But the scan body also holds another important part when it comes to integration, right?
Right, because as you saw in the library structure, it's always connected with all the other parts, with all the other digital files and the physical components.
Exactly. And as we talked about with the open digital workflow, one of the things that I truly pride myself off with the Elos digital workflow and the Elos Accurate scan body is actually the integration bit that we succeeded to do. So starting off on the Elos Accurate scan doesn't mean you have to follow an Elos Accurate path, basically, with the digital workflow.
This is the idea of the open digital workflow, I think. It's not just related to one portfolio or to one library. So we can use also original brands, because the Elos scan body is also implemented in different original brands library, but also can go to the Elos library. So we have a lot of options.
Exactly. And as you see here on the slide, so the Elos Accurate scan body is actually part of all these original workflows. We have Biocare, we have BioHorizons, it's part of Identica, and also the Straumann library. You can do an original barrier based off a scan of a Elos Accurate scan body. And we also have like Neos, and we have Dental Rona, which we have had a long cooperation with.
That's a really important point today, because when you get intraoral scans, you don't have the sovereignty about choosing what kind of scan body. So usually your dentist sends you a scan, there's a scan body on it. Now you want a specific feature in the library, but it's not connected with that scan body. So this scan body from Elos enables you to select different libraries, different original brands, but also the Elos Medtech library.
Exactly. So you're saying that the clinics or the doctors are actually setting the path of the final reservation by choosing or the choice of scan body.
Yes, in general it's like this, but we will show you in the next section.
We have some
tricks, yes,
looking forward to it.
To how to switch from an existing scan body to another library.
Okay, Ralph, well, let's have a look at the first tip. So what you got for us here?
Yes, it's about a question what we talked about, especially with intraoral scan. You don't have the sovereignty about the scan body. So I think you always receive scans with different scan bodies, but you have your preferred indication or abutment application. So the solution could be to switch from an existing scan body into another library, and this is shown in the video.
Okay, so how do you actually do this? It's just you need to go into expert mode, as I saw here.
Yes, for sure. So in the first step, you're using the right library that matches the scan body you have in your scan. Yes, but then you go to the expert mode. Yes, and into the expert mode, you made a right click on the scan data, and in the appear menu, you choose the switch implant connection library button. Yeah, it's a long word. But it's okay. So then there it goes up another window. Yes, which is the switch implant connection library window, and then you see all the compatible libraries.
Okay, so you only see what is enable you to switch between the libraries.
Right, that is important.
Okay, and that's because Exocad is kind of governing and making sure that the libraries fits to each other.
Yes, for sure. If you are selecting a specific platform with the right scan body in the first step, then for sure you just see the compatible libraries which are related to this specific platform.
Okay, meaning that if a library is not set to be utilizing these options, you won't be able to see it.
Yes, this is right.
Okay, okay. So this looks really good. Of course, this is Exocad, but can you do this in other softwares as well?
Yes, for sure you can. It's a little bit different. I think too much to explain here, but in 3Shape you have the global coordinate system,
Which basically allows you to do the same thing.
Right.
Okay, and just looking at this video, so I see you actually convert the entire library, because you also get the analog from the library you switch to. It's not only the prosthetic parts, but you're actually working in the entirely new library, even though you started off with another library.
Yes, you're absolutely right. So you can easily switch to your preferred application.
Okay.
Especially maybe for the implant model, you need a solution to make your digital implant model. Yes, and so you can switch easily to the Elos PMA, for example.
Okay, so this is in essence the open digital workflow that allows you to work between different workflows.
Right.
Perfect. Really good trick, Ralph. So what's the next trick you have for us?
The next trick is about maybe you have sometimes holes or artifacts in your scan.
Okay.
Yes, especially when it comes from the patient's mouth.
Okay, so I guess here you try to replicate some kind of error that could be the library.
Yes.
Like
I had just good scans, so to say. Yes, so I made a little bit with my mesh mixer software to generate these holes and artifacts.
Okay, so what we're seeing here, you're trying to do a scan body alignment.
You see there are holes in the matching. When you go in the matching process, you see it's not really good aligned. You see this false color, yes, and the red and the green, and it's not good. So, but you have this slider beside the scan body, so you can shorten the scan body from the bottom to exclude these artifacts.
Okay, so you're actually only aligning on what's important and what's good.
And that's what you see now here in the video. Now everything is blue, which means you have no deviation, or 0 to 5 microns, not more.
Yeah, so really high accuracy.
Absolutely.
Okay, so by using the slider, you're in theory forcing the software only to look at the bit you want to align to.
Right, that's the reason why we did that, and I think that's a very important. It's a very easy to use. You don't have to go to expert mode or whatever. It's directly visible in your matching scan body window. So easy to use.
Great. So how is it you get this color mapping when you do the alignment? You need to click on the best fit, and you need to hold what is the control key down.
Yes, you have to push the control key together with activating the best fit matching button.
Okay, and that allows you to see this color mapping.
Yes, maybe another trick.
Yeah, it looks good. It looks good. Okay, so for the final trick, what's that, Ralph? So what are we looking at here?
Yes, this is more a rather case. Sometimes the scan body cannot match. Yes, also the scan looks visually good.
Yeah, but you see the scan body scan here. It looks correct, right?
It's not matchable. No. However, yes, but so you go to the expert mode, and then you click on the mesh you want to edit, and you click on the scan data editor. And if you go now with a right click on the scan data, you see there's a appearing menu, and this shows the triangle orientation, and it's getting red.
Okay, so you actually see what you're looking at is an inverted mesh.
Actually. Right.
Okay. So, but it doesn't show that from the beginning. It's still green. Everything looks right.
Right.
Okay.
So, and this gives you the opportunity to re-invert the mesh again. So, if you go again on the scan, then you have this nice feature, invert triangle orientation. Yes. And if you select this option, this will correct the triangle orientation. So then you can click OK, close the scan data editor, and restart the visit and proceed with your scan body matching process.
And now it matches.
No, it matches.
Okay, right. that was a really good trick. I've never seen that before, and I could certainly understand that this would be kind of annoying if you're trying to align the scan body and just like you can't really force it in place. But good trick. Really good trick.
You're really getting crazy if you have this problem.
Absolutely. I think that will help a lot of people.
Yeah. Hopefully.
Yeah. So thank you for this webinar. been a pleasure, Ralph. Really nice hearing all your tips and tricks, but also your deep knowledge within the digital workflow.
Yeah,
been a pleasure.
Thank you, Kasper. Always a pleasure for me. Thank you to the audience to join this webinar. And maybe we will see us in the next webinar.
I'm looking forward to it, Ralph.
Okay, thank you. Bye-bye.
Bye.
Installing implant libraries in Exocad is very easy in the latest version. When selecting your implants from your menu during an implant design, if you go through that menu and you find you're missing the implant type that you need, simply go over and click on Download More Libraries. That button will open up a Exocad Library Manager window. And inside of that window, you can search for the implant libraries that you wish by clicking on the letter of the alphabet. You can go ahead and select any number of implant systems in this menu. You don't have to just do one at a time, but expand the implant type that you want and just make sure you're choosing the right type from the list. Click Add to Download List on all the applicable items. Implants usually have an implant set and then an analog set. Sometimes they have more, sometimes they have less, but usually they'll have a implant library item and an analog item. Once you've selected them, go to your downloads list, fill out your information. This will be your own information and the information about your lab or clinic. Go ahead and click on the acceptance buttons and install libraries. This will download the list of libraries that you've selected. And once they've downloaded, they will also install. When you're presented with the list of what to do, it's basically asking you if you want to replace the existing libraries if they're already there, or update just the items that are different. I think it's usually a good idea to always replace with the newest items you're downloading. Once you're finished installing them, you'll need to close Exocad and reopen it for those new libraries to be detected. And go ahead and start your design again. And when you get to the implant selection menu, you'll see that you have whatever items that you chose in that menu.
So with ordering Elos products, you'd basically go
come
to
the
Emerald Dental Works website, and we have various different, all our products that we have there. You go to the shop, we have scan bodies, hybrid bases, and base screws, Elos tools. So we'll go to analogs, scroll down. These are all the products provided by Elos. We'll hit Straumann bone level. It's a 4.1 RC. Grab the analog. Scroll down on our website, shows you what's available for that implant and that analog. And we're going to go say, hey, we'll add the analog. And then we'll go say, hey, we need a hybrid base. When you go to hybrid bases, we show two things here: is a hexalobular screw, prosthetic screw, and the Elos prosthetic screw. If it's an angulated screw channel, you go with the hexalobular. And if you go with the hexalobular screw, you also have to order a driver. If it's just a straight channel with the prosthetic screw, you can use the implant screw for that specific thing. So for their specific implant. So when you check out, fill everything out, and you continue to shipping, and you can say next day, 4 days, whatever. Our experience is everything's next day because everybody needs it next day. But what we find also is that when ordering, the toughest part for us as a supplier is trying to read everybody's mind in Canada of what products they need, even from analogs to hybrid bases and everything else. So what I would think would be great for you guys is for labs, if a case is coming in and you gotta, that case in, as soon as you see that case come in, if you know what PMA analogs you need, order them right away. We have been guilty of back ordering. Usually Elos is very good at responding to our orders and getting it to us we get it in within a week from Elos usually on a regular basis.